Okay. So, today I would like to work a bit more on the upgrade system and the upgrades you could get. There's a bunch of things to do, and the first thing that comes to mind is adding an upgrade which would allow you to get several purchases in one go once you win a level. That is, if you have sufficient funds. Uh, and I think it should also be spawning kind of randomly. But once you get it, you can make more use of your funds. And ideally, it should spawn uh, maybe somewhere like halfway through through the game, so that you can prepare for the final boss a bit better. Uh, that also means I would have to make unique type of upgrades that can only be purchased once. It of course could be a stackable type of upgrade. For example, uh, there could be an upgrade which provides you with more options, and there could be a separate upgrade which provides you with stackable purchasing power, but it might be a long shot at the moment. So maybe it's a good idea to just start with implementing unique upgrades, and then we can see where we go from there. Okay, let's see. Okay. So the first thing I would like to do is, let's see. I wonder if the stream is doing fine. I'm gonna quickly check if that's the case. If all the sounds and everything comes through. Uh, Let me just double check before I continue. Yeah, everything seems to be in order. Okay, this is fine. Let's see what we're doing here. So I would like to start in the state. Now, what does a state look like? We have a player state, and it should be saved in this object. It's very hard for me to come up with perfect names right away, so it's all subject to change, of course. Let's call this thing upgrades. And upgrades should be an array of type. Well, ideally it would be a separate enum, a separate type with just the player upgrades. Uh, but for now, for the sake of brevity, maybe it's a good idea to just use this enum that we have here. And whenever we are creating the player state, which is happening here, I want to just initialize it to an empty array. I will just copy this line here for now. And now when we go to, well, first of all, let me not forget and add an actual upgrade to the enum. And we can call it upgrade purchase multiple. Purchase multiple. There there is also going to be, well, I need a button to also kind of exit the upgrade screen in case I don't have enough funds to purchase anything really. I'm wondering if the button should be, in terms of code, should be visually looking like an upgrade button, because it could save me some coding time, but maybe no, maybe that's not a good idea. Let's not let's keep the concerns separated. Okay, upgrade purchase multiple. This is fine, of course. It's going to break because of the types, because of the record, which is upgrades over the properties of the upgrade, which forces me to add the actual upgrade here, and it's called purchase multiple. And the price should be, I don't think it should scale with difficulty. I think it should be a one-off. And the price, well, if you have a lot of money, then it's going to be useful, right? Because you're going to purchase several upgrades at the same time, which means that it should uh, cost a significant amount, because you know you have money anyway. So let's say this thing is 10,000. I'm just eyeballing, and we are going to also affect the balance and update the balance. And when it comes to state management, the only thing I really need to do is upgrades. I need to push. Maybe I shouldn't really push, Maybe it should be a map. But in the end, it won't really matter because these are unique upgrades, and I just need to make sure I'm not populating the initial list I'm going to iterate over to create the buttons with this upgrade, so it should be filtered out prior to the generation, and then it should work. So I'm going to keep this as an array, and I'm going to push the upgrades dot purchase multiple, which is great, and on the next victory you will get to make use of it. Another thing I will need to do is I should probably have like a different sprite for this, which I'm going to return to shortly. Now, when we need to rewrite this function, because currently it just makes a random pick out of the enum. We need it to be smarter. Um, we need it to be smarter. So we would need something like an object, an object which has well, I have that kind of an object already, right? And maybe I should just add it here, and then what's the best way to do this? Hmm. Maybe it would be easier to read if I have a separate object just for tracking the probabilities. And I'm going to do something like this. And it's going to be a number. Uh, now, this is going to be relative, right? So let's say we have seven entries, right? Which means that we're going to have something like this if the probabilities are equal, which is going to be 7. And to get the probability, for example, of this element, I would need to measure it in relation to the other entries. So if there are 7 elements, then it means that the probability, and if the weights are equal, it means that it will be 1 divided by 7. Yeah, I think I'm right. Might be wrong. I'm used to being quite stupid when it comes to simple math. But so basically I just need to add these numbers up and divide. If I have 7 upgrades, for each of the upgrades I need to add these numbers up, and then I need to divide the weight of the item in question. And let's see. Let me do something really quick to just make sure my mediocre math skills are on point. So let's say we have an array of 10 elements. One, two, three, 6, 9, and 10. And then I want to reduce to get the total amount of weights across 10 elements, right? So I'm just going to do return accumulator plus element, which returns 10. And then let's say if I'm dividing 1 by 10, it should naturally be 0.1. And let's say the item in the upgrade in question, the weight in question, is the first one. Let's say this is 2. And then this means that the total weight is 11. And then the weight of 2 in 11 is 0.18. Okay, if this is 19, no, 21, or let's say 11, right? Then it kind of has the in total we get a weight of 20, and then I divide 11. Yeah, this seems to be right. If we have 10 elements and then 5, the weight of the first one is 10, we divide 10, we get the probability of this one. This seems correct to me. Maybe I'm extremely stupid, but I will roll with it for now. Let's see. So basically, if I have this object with all the probabilities, I can get the total weight, and then I'm going to iterate I need to think. Because the result needs to be uniform across iterations. Mm. This is interesting. Seems like it's called an alias method. Uh, let's see how smart people implement this. So we get the input probabilities. Constructing the alias table. remaining space in an underfull cell will be filled by surplus space from an overfull cell, such that the underfull cell becomes exactly full. The overfull cell will then be reclassified as to how much probability it has left. Here we are collecting the probabilities and checking if they are a number, and then the sum of probabilities we calculate like so. And then we scale all of the probabilities such that their weight, such that their average is 1. Okay. If all of the input probabilities are the same, then they're all set to 1 by this procedure. Okay. Length, okay. The probability multiplier. So if we have yeah, this means that if we have, for example, 10, we divide it by 10 total, then it becomes 1.9, which is the probability multiplier. And then probabilities, P multiplied by probability multiplier. So basically we do something like this. Okay. Which ensures that the average of these things. What does this? Am I doing this correctly? Average is 1. So does this mean doesn't seem like so. Probabilities. Oh, no, 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 no. If this is 19, then it means I have to basically do 10 divided by 19, which is this. This was my bad. And then I need to do this. And now the average here should be 1. If we reduce and we do return a plus b. Yes, and now it is almost 1, so this is fine. So the probability map has been scaled, and then sort the probabilities into overfull and underfull queues. For each, if p is okay, so for each of the probabilities, we check if it's over 1, then we push it into the overfull array, and if it's less, then underfull. Otherwise, if it doesn't equal 1, it throws an error. And if it equals 1, then I guess nothing happens. Right? Seems like it. Okay. So we have the overfull and underfull arrays, and then we construct the alias table. In each iteration, the remaining space in an underfull cell will be filled by surplus space from an overfull cell, such that the underfull cell becomes exactly full. The overfull cell will then be reclassified as to how much probability it has left. Okay, so now the overfull, if either of them has some items in it, then we continue to check if the overfull lengths, if both of them have some items, then we pick the aliases of underfull 0 equals overfull 0, and then probabilities. Okay. Okay. And then we keep doing this entire thing while so one of the arrays have any items in it. Okay, so we just pick the first assign, and then abilities. Okay, and then we remove one of the items if probabilities or full is greater than 1, then overfull push, and we shift one of the items. The average of probabilities is 1. Mathematically speaking, this block should never be reached. Posed by floating point numbers, a tiny bit of surplus can be left over. The error is typically negligible enough to ignore. Known empty array equals overfull length is greater than 0. Create and return the sampler. With the creation of the alias table, each box now represents a biased coin. Its possibilities are either it or its corresponding alias. Sampler picks one of these coins with equal probability for each, and then flips it and returns the result. Okay, uh, let's take a look and make sure we get this correctly. Sampling from a discrete probability distribution returns integer values between 1 and n according to some arbitrary probability distribution. The algorithm typically uses O n log n or O n preprocessing time, blah 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 blah. Internally, the algorithm consults two tables, the alias table to generate a random outcome, a fair dice, determine the index based on the probability stored at the index. A biased coin is then flipped, and the outcome of the flip is used to choose between a result of I and ki. Okay, let's see if there is an implementation that could be played around so that I can get a feel of how this works. No. Interactive alias method. Seems you have a function for rolling a fair dice and flipping a biased coin. Nope. Okay. And in the end, this returns a function which has the weighted probabilities through a closure, and then we do a sample. Well, this seems like exactly what is needed. Let's see if we can make this work. We can just inline the function and see how it behaves. Const sampler, and we get the input probabilities. Okay, and we get an index. Or the aliases index. And the order, I suppose the the order is preserved. I want to check if the order of the keys, if I can rely on the order of the keys. Object dot keys. I don't think it's guaranteed by the standard. Let's see. Well, I would need to reduce the level time. Still going right. Yeah. So this seems to be preserved. Object dot keys order. Does not always follow the insertion order. Ascending order. Okay. And since we have the string keys, we are fine. Yeah, so then this is fine. This is fine. This means that we are guaranteed the order of the string keys in an object, which is great. Hey, Jamie TRL. Okay. So I'm assuming that in the end I will get the index in the probabilities object, and then I can pick the key, which will be the upgrade in question. Let's see. Let's try and implement this. So we get our probabilities. Uh, we are mapping. We should just reduce. Uh, okay. We call it sum. And then we need a multiplier, which is the length of the probabilities divided by the sum, which is going to be our multiplier. And then we need to okay, and thus we are ensuring that the average is 1 or very close to 1. Okay. Now we have this overfull and underfull queues. Oh. Underfull, and then we need to go through adjusted probabilities. Maybe it's better to call it pre-multiplied probabilities, and for each we are basically performing a simple check. If it's greater than 1, then we push in the overfull, and otherwise, if it's less than 1, then we push it into the underfull. We need to connect the index. Okay, and that should be Well, there is a check. I don't think it should happen honestly, but let's see. So we're pushing the indices. Okay. After we've done that, we need to construct the alias table. Filled by surplus space from an overflow. Okay. I guess I can just copy this thing over and see if it makes sense. Uh, yeah, so we pick the first one from each of the queues. And then we check for pre-move full length. Under full, and then we remove one element. Okay, and if okay, because the average of all the probability is one, now we reached. Okay, okay. All right. Yep, yep. So we pick whichever has some leftovers, basically. And we set the indices to 1 and non-empty. I think this line is a bit unnecessary because these are just numbers, like, and it's, I think this is an unnecessary line. And finally, there needs to be a function. Let's do it in const sample, and we get we get a random index. We get a random index from 0 to probabilities length. Oh no, pre-multiplied. Well, it doesn't really matter. Length minus 1. Yeah, I think this should be good. And then we return and then to test this, we pass in the values of the weights, and we get a sampler function. And so let's say return the sample, and we call it 100 times. Now it won't be as trivial. Let me remove the state, and I want to okay. Okay, maybe it's not very easy to see the spread. Oh, we can actually do this. dbg join. Okay, now let's say we only have 2 items, and then the probability of the first index is 0. Perfect. And let's say the probability of this index is 0, then it's going to be just ones. Yes. Now let's say the probability of this is 10, and the probability of this, the weight, is 1. Let's see, it should be ones and twos, but ones primarily. Okay, I think this just froze in an infinite loop. Well, let's see what we can do about it. So this is 0, 10, 1. This part is correct. And then the sum is 11. The multiplier 0, 27. Pre-multiplied probabilities 2.72 and 0.2. Now what we want to do is populate this over full and under full. Well, this part seems a bit confusing. Greater than 1. Oh no, this is actually fine. So if probability is greater than 1, it's only happening in one case, which is 2.7, and the index is 1, so the overflow goes to 1, and underflow goes to 0 and 2. So this is correct. Now, while overfull length or underfull length is greater than 0, if both is greater, yeah, then we populate the aliases. Pre-multiplied probabilities. We take the overfull underfull. Okay, and this is a bit confusing to go through. And now we have the underfull that is not empty, and then which is okay. Okay. Okay, and this both. Uh-huh. Okay, so this is where this is happening basically, because yeah, okay, so this indeed makes sense because it's just nullifying the array. This is entirely my bad. This makes perfect sense. And so this should fix it. Let's see. Let's see. So this is roughly 1 in 10, but the caveat is this has to be sorted. Yeah. Yeah. Cool. So, okay. But then the ones, yeah, okay. So we have the 0, we have the ones, and primarily 2s. However, if we do this, okay. So we have 7 in total, which means, yeah, I see. Okay, we have a lot of 6s. Then 1, 2, 3, 4, 5. And then if I want to get rid of 6s, I set it to 0. Let's see how that behaves. Yep. Now, if I set the 3, 1, 0, 1, 2, and 3 to 0. Yep. Yep. Okay, well, this is great. Now, let's say the probability. Let's play with the probabilities now. So I want the unit warrior to be more prevalent. Let's put the weight to, let's say we start with 10. Sorry, not the warrior, but the ranged. The warrior to 1, keep difficulty. Let's start with 100 and upgrade inventory and keep difficulty and purchase multiple. Should be like this. Unit warrior is kind of expensive, so maybe the blacksmith should have 70. Unit warrior should have the weight of 50, and then stone golem the weight of 10, and maybe keep difficulty I would say this should be 50. And then once we purchase it, we set it to 0, so it never shows up. And then keep difficulty maybe 40 and upgrade inventory. We can probably adjust the rarity as the difficulty progresses. So this means that let's maybe keep it at 40. Great. Now we have this thing going on. Let's see. And we have our sampler functioning. And now let's see what it spits out across 100 iterations. Okay, so the unit range, which is 6. Let me just copy this and we check for the 6. Okay, so it's pretty prevalent, and then the least prevalent is 0. It's the stone golem. Yep. And then 50, 70. Let's check for the first index. Okay, keep difficulty second, third, fourth, fifth, sixth. Okay, this is 9, 12, 11 to. Well, this seems about right. What if I do 1,000 samples? Let's count. That's a lot of numbers. Okay, let's go. 6. Nope, 6. 153. 5. 216. 171. Okay. So maybe decrease to 5, 10, 10, 20, 30, and 50. Six, 5, 4, 3, 2, 1. Great. So this seems like good enough. Now that we have this thing sorted, we can do not the random pick here, but we would like to do the following. Wait, we do sample. No. Would like to convert object keys, and provide the weights, and then here we do sample as upgrades. And maybe, let's see, before I do this, I would like to just double check this works as intended. Like so. Okay. And then we can search for this. Yep. Yep. Yeah, this is correct. Okay. No, 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 no. Object keys, weights, sample, upgrade. Let's check what we get out of this shenanigans. Okay, sounds about right. Okay, so one of this is the inventory, and this is multiple. So this is fine. What was at 50? Oh, this is not inventory. This is keeping the difficulty. Okay, let me increase the balance. Huh. Okay. 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 Well, yeah. This the mountains level. It's not. It's not implemented. Oh no, no, it is implemented. I just updated the amount of seconds to debug levels just in one just in one of the levels, the grasslands level. Okay, this is great. Maybe I should tweak the probabilities a bit more. Maybe also uh, let's tweak it a little bit to 150. Now it feels like the probabilities should be living in the state, because if they are, they can be consistent across reloads. In case I change the probability, like, which is also like makes me think that since the drops and upgrades can have probabilities, it could also be a part of the game mechanic, because implicitly the probability of at least one of the upgrades is going to change, which means that by having a certain type of a character in your inventory uh, could favor the probabilities in some direction, could skew the probabilities, which is an interesting gameplay uh, mechanic. But that's for later. Let's focus on making sure that the probabilities live in the state, and they should live in the yeah. So this means that I need to change the structure. It means that when we have a state player, instead of upgrades, because or no, no, we can't do that. I don't want to infer the presence of an upgrade based on the probability it has. So if, for example, I just have the probability, the weights, the weight distribution here, and then once I purchase, the weight of the certain upgrade becomes 0, it kind of means that I have acquired it, but that is only for now. Because in the future I could zero out the probabilities for some other upgrades. It doesn't mean I have acquired them. It means they're not spawning. So this should be kept intact, and we should add the weights here. And the weights is going to be of type record, upgrades over numbers, like so. And this means that we now need to come here and implement this here, which also means a comma, which also means that it should be reflected here as well. I don't like the duplication. Maybe but having too many functions is also kind of confusing. So I'm not gonna screw with this. Okay, so we have the weights. Um, so we don't really need this for now. And we need to retrieve the weights from the state. Player, which is not this, it's just state player weights. And we do this, which also means that I need to rewrite the state. Which also means that when I make a purchase of the upgrade purchase multiplier, I need to add the upgrade to the upgrades list, and I need to modify the weight of the upgrade. State player weights upgrade purchase multiplier equals 0, so that it doesn't spawn anymore. And also, while I'm here, if I have this upgrade present, it means that I shouldn't unmount the vendor. And where do I perform the unmounting? I think it's done here somewhere. To the dead flag. Yeah, okay. So the dead flag should be only set to true. So it should be set to true in case I'm out of upgrades to purchase or I decide to exit the vendor. So when it comes to here, well, this begs for refactoring, but first I need to make sure it's working. Let's see, in case player upgrades. So we need to get this thing. And then if upgrades includes, can purchase I don't track. I don't track. Yeah, okay, I don't unmount the vendor buttons separately. So I need to implement that first before I can continue. Which means that I need to ask the component controller to unmount I need to ask the component controller to unmount the button first. Which means that I need to know its universal ID. Which means yeah. So basically when I'm calling the on pointer down, it is giving the ID. Yeah, it is giving the ID, which is great. It's exactly what's needed. And then I can do this. Let's copy the signature. Okay. Signature is updated, which means here I get the UID, which means I can ask the component controller to unmount by UIDs, and I supply the UID. So now this is working properly. And then I need to do the same thing here. And we get the UID. Now is only upgrade left. Now I can just query the buttons in the component controller to see how many tags. Okay, get. And then I can provide the class name, rather the constructor name. And then length equals to 1. So now, if I can't purchase multiple, or if only one upgrade left, then we mark the vendor to be dead, which will imply it's unmounting on the next tick. So now basically all I should do is copy this thing, and let's see if it makes sense for the upgrade purchase multiple. Can purchase multiple is true by default, so we don't need this check. And for the rest of them, it should be the same. So I just do this. And here as well. We'll do this and this. So this seems to be a correct implementation. Now, to test this thing properly, I need to upgrades unit warrior. Let's do the following. We don't need an erasure. We can just do this, and then we can comment this out. And here what I want to test. Oh, there is another corner case. We can handle it here later. I'm going to add a comment so I don't forget. Only spawn one upgrade purchase multiple. Because it doesn't make sense to have two of the upgrades. They should only spawn one at once. And now let's set the probabilities to 0. Upgrade inventory 0. Keep difficulty 0. Purchase multiplier. Let's say 1. Unit warrior. Say 5. And let's see how this works out. Okay. Oh, I don't have enough money. Well, that's not an issue. We just add lots of money. Okay. Let's go. Okay. This works. Now I get to select this one. This is absolutely beautiful. And then I get to select this one. This doesn't self-destruct, which is because I made a mistake somewhere. Oh, of course, of course. Yeah, so basically the argument is getting shadowed by this. I need to fix it. Yeah, it should only happen 3 times. And so I need to change the name to occupant UID. And then I need to supply here and here. Why is it complaining though? Oh, well, that makes sense. This should work now. Before I save and reload, I would like to go and save the state to see what it looks like. Player. Okay, now I have upgrade purchase multiplier. There is a typo, which is not good. No, no, upgrade purchase multiple. There is no typo. This is correct. And upgrade purchase multiples weight becomes 0, which is exactly what's needed. Now I can save this, and I should only be getting the ranged units from now on. Okay, there is a crash. It doesn't like the despawning. Let's see what's the issue here. Upgrade. Oh, which is correct because I also forgot to fix the populate function call. So this should be working now. Let's see. I win. I can purchase more. This is perfect. I go to the next level, purchase more. I go to the next level. I purchase more, etc., etc. Now, if I remove the state and okay, I have the money. Now, if I go, I should get the upgrade once. Sometime. Yes, I got the upgrade. And now I can purchase multiple. And now I'm not gonna get the upgrades anymore. Yes. Okay, I'm satisfied with this. Now, another thing that is left, if I flip the odds and I do this and I clean the state, I'm gonna be getting several of this upgrades and I should restrict it to just one instance. Well, there is a nicer way to do it and there is an uglier way to do it. A nicer way to do it is to have a local weight distribution in the function. So in case I spawn one of this, I alter the local weight distribution. But then, no, it's not actually that nice because I need to update the sampler function. Is it nicer though? It's not. Well, it has a while loop within. Uh, it might be easier to keep re-rolling, I guess. Though it's not very beautiful because it could potentially increase the cost of the function based on the randomness. And it would become probably more obvious once I start playing with the probabilities in runtime. a bit more. But I would say it's not that big of an issue. We will iterate on this in the future. So for now, let's see. Keys player waits. Hmm. No. Mm. It's easier. It would be easier to read if I change the sampler. Probably. It would be faster also to write. So first of all, I would like to take the sampler function and I'm going to extract it into the utilities. Uh, alias sampler, and we do this. But also, I'm going to make a clone, a deep copy of the weights. To use here, and then I'm going to do this, and I'm going to do this. So now I'm working against a local copy, but before I do that, I need to save the result of the sampler. And if upgrade equals to upgrade purchase multiple, then here I'm going to set the weight distribution to 0 for this upgrade, and then I can do this. This means that now there is no way for me to get two of purchase multiple upgrades. And let's see if that's the case. Yes, perfect. Let's try one more time. Yep. Now that I've purchased it, I can purchase more. And now I shouldn't be seeing it at all. Yes. Yeah. Perfect. Now, one thing that I'm gonna do before I take a break is add the option to exit the vendor without purchasing anything. And to do that, I need to let's do it a bit dirty and just add another text exit. And I'm done. No. Okay. Well, ideally I should have a button UI element that is like not the button, but not a slot button, but something else. Well, let's just call it exit. Anchor scale position, let's say 70. And we also need to make sure we destroy the object when we unmount. Okay. Exit looks weird. Maybe it should be okay. And then I also want to make sure that this object is clickable. Let's add the event mode, and we need to make sure we have a callback. Let's see how I did it previously. Dude, where is the button? Here. On pointer down. This is the thing. And here all I want to do is to mark the vendor as dead. Which is this dead equals true. So now when I go here and I win a level, I can press OK and I can continue without buying anything. I should probably add a cursor. Okay. Okay. This is good enough. I can do this. Okay, now before I go, I need to let's return the amount of seconds and let's return the probabilities. And let's set the balance to 100. Now start with 100. We get the guys. They're free for now. And now we can see if everything holds up. Okay, since this is the first time, the first level, the price of the upgrade to keep the difficulty is 0, and I can continue by collecting everyone from the battlefield, and so it's level 0 again. I missed the level name, but it should have been level 0. Okay. Well, there's really no point in buying because I just lost money at this point. I didn't have enough slots. Okay. Now this is the price of the keeping the difficulty, and it's 50 because it's the difficulty 1, so it's multiplied 1 multiplied by 50. And I don't get any good updates, upgrades, so I'm just going to continue on level 1. Well, this is not too much fun because the balance is way off. I guess the first thing is to make sure that the systems are in place, and then I would bother about balancing everything later. The prices are way off, so the early game is really kind of unfair. Yeah, I should get the I should get an empty slot earlier, which means that the balancing would imply that I change the weight of everything that's happening based on the level I'm at. So, for example, if I'm uh, like in the level that is below 10, then the probability of you getting an inventory slot is much higher. So the weight of the inventory slot would be higher. And then it goes down as time progresses. And also with this system, I can make sure that I can never get more than 15 inventory slots, because at some point I can just decide to drop the weight of the inventory slot to 0, and then it never spawns again. Yeah, that seems like a good solution to the balancing issue. Yeah, I guess I will need to, like, when it's done, when the system are in place, I'll need to play a little bit, do some play testing, and then uh, kind of write down all of the issues I'm having with the game, and then I will be able to make like a better, like an educated guess on how the weights should be distributed. Well, I'm gonna take a break now. Uh, Thanks for watching. See you next time.